Again, I've got connected to an Intel version of Debian here. So now let's try doing these installations, because this is a brand new Debian machine I just brought down. And we're here. So let's first do the sudo apt update and then try installing that stuff and see what happens. When I tried to do it earlier, I was on an ARM machine, and that led to insolvable problems because I could only write ARM assembly on this ARM machine. I forgot about that. So if I install this, we'll see what it takes. That's why Build Essential gives you compiling tools, and NASM you need to do assembly language compiling, and GCC Multilib will let you compile 32-bit code on a 64-bit machine. That's the goal here. And this is what happened at home. Everything works except Netcat, but it tells you what to do. Choose one of them explicitly to install. Netcat OpenBSD, for example. For some reason, they've decided to break it into two versions and require you to explicitly tell it which one to install. So it doesn't matter which one you install. I just did the OpenBSD one. Whatever the difference is between them, I don't care. We're only going to use the basic features of it. And so those are the commands that will work on an Intel processor. And you're not going to be able to do much of this. I don't think you'll be able to do any of this on a Debian processor, on a ARM processor. So you have to use an Intel hardware or a cloud machine, which are all Intel currently. However, it reminds me, if I get time for my other projects, maybe I should write some ARM assembly coding projects, but I don't have them yet. And by the way, you can emulate Intel on ARM for Linux, and there are at least the other way you can do it. Anyway, so here we are. So it's installed all that stuff, so now we can make a program. I'm just going to make a directory, 126. I don't know if I'm going to use this machine enough for it to matter, but it's sort of like to keep things neat. All right, so nano hello.asm. All right, so here's the code that says hello. All right, so what you got, you define a text section and a data section, just like we've been doing with Windows malware. And in the text section, it's going to just do two calls to int 80. Now, these are called syscalls. This is how you do everything. These are the system libraries. Remember, I've said before, a Windows program is just a bunch of calls to Windows API, which is true and it's every other operating system too. Int 80 is the way to make a raw syscall to the C library, essentially, in Windows. So what you do is you fill these registers with codes that tell it what to do, and then you call int 80, and it will perform the activity. This is how you make the jump to kernel mode so it can touch your hardware. And so what's going on here is this is what prints out a message. And we'll see the syscalls in this tutorial. Yeah, I have listed them here. So 4 is syswrite. That writes, and 1 is sysexit. And so then you just tell it what to do by filling the registers. So you use EAX to tell it what the syscall is. And here, if you're writing something, then EBX has the, I think ECX has the pointer to the thing, the text, and EDX is the length of it. So if you look at what this code does, it loads EDX to be length, the length of the message. It loads ECX to be a pointer to the message. EBX is 1, I forget what that is. And 4, oh, that's the device number to write to. So device number 1 is standard out. And 4 means write. So this whole thing adds up to the C line, print F, to print something. And this is what the assembler does. It lets me give names to things instead of having to have hex values for everything. It lets me define a data section with a label called message, which points to the start of this thing, and then a length, which you can calculate by taking this point minus the start of that. So it'll automatically calculate the length of this, and that's where I get these two parameters. So this is, all this assembly code amounts to one print statement in C that will call the syscall that will perform print. And when you save this, Control X, Y, Enter, compiling assembly language is a two-step process. First, you use NASM to make 32-bit assembler code. ELF is executable link format. That's Linux-based code. And then you link it to to the libraries, the LFI386 libraries, which came from that multi-lib thing that let me compile 32-bit code on a 64-bit machine. So now if I do ls-l, I have a thing called hello that's executable, and that's the program. And as you can see, it prints hello world, and I didn't tell it to put carriage return at the end, so it doesn't. But this is about the simplest program you could ask for. All it does is print hello and then exit. So let me check for comments in the chat. There, which would be here, except I have to somehow make them pop out, and I guess I can't without making the window bigger. All right, there. All right, good. No new comments in the chat. All right. So that's the first thing you do, is just say hello world, and that shows you how we're going to do everything just by doing syscalls, int 80 to do everything. So those are the two sections, text and data. The start label, by the way, tells it where to jump in to enter the program. So let me bring it up here again. If I just go back to Nano, start tells it where the program starts. It needs that, so it knows. Then it executes these commands in order. The data section is separate. So this is what does a print. This is what does an orderly exit. And here's the data section. All right. All right. So now that's syswrite. All right, and sysexit. Okay. There's the data section. Okay, so then there's a bunch of flags you find just by reading this tutorial, which is very nice, which will teach you a lot of basic things. The sections, the various types of registers, various types of syscalls, various data sizes for different purposes, how multiplication and addition and subtraction work, and XOR and NOT. There's just a lot of things you can learn here. If you wanted to go through it, this is a good idea to get basic training in the syntax of assembler. So that's the first project, and I'm going to stop this recording.